Welcome to section 6.5, Operation with Radical Expressions. Now before we get into the work of operations, we're going to review with simplifying radical expressions, because you need to know how to do that when working with operations when you're trying to solve or simplify these radical expressions. Now before, we have done this in the previous sections, in the previous chapter, but again, this is just a little review. So over here I have the square root of 32. So I can simplify that. The reason because 16 and 2 can go into 32, whereas 16 is a perfect square number. So here I've broken down 32 into 16 times 2. When it's multiplying, you can split it into two separate square root. Now, if you know that 16 and 2 can go into 32, you can just go right away into writing square root of 16 and square root of 2, but remember, they're multiplying to each other. Now, the only one that I could simplify, meaning I can do the square root, is the square root of 16, which will be 4. Since I cannot do the square root of 2, I just bring it down and then put it next to the 4. And then my final answer for square root of 32 is this. Alright, let's do the same thing for square root of 24. I can break this down into 4 and 6. And again, the reason I'm using these two numbers is because 4 is a perfect square number. Since they're multiplying, I can break it down into square root of 4 times square root of 6. Now, I cannot break down square root of 6 because the factors for 6 would be 2 and 3. Neither are perfect squares. So I'm just going to leave it as square root of 6. The only way I could do the square root is 4. So I'm going to bring it down here. The square root of 4 is 2. And again, I cannot do the square root of 6, so I'll just put it next to the 2. Like so. And then that is my final answer, 2 square root of 6. Alright, the last one, this is a cube root because we have an index of 3. So the cube root of 128 is not a perfect cube, so I have to use one of the perfect cube numbers for 128. So the only one that's closest to 128 is 64 times 2. So we're doing the cube root of 64 times 2. Or I basically break down 128 into 64 times 2. Again, since it's multiplying, I can write the cube root of 64 times the cube root of 2. Now the only one I could actually do the cube root of is 64, which is 4. And again, the cube root of 64 is not the same as square root of 64. So make sure you know your perfect squares and your perfect cubes. Since I cannot do the perfect cube of, since I cannot do the cube root of 2, I'm just going to put it next to here, next to the 4. And that is my final answer when I'm trying to simplify the cube root of 128. Alright, so we're going to talk about adding and subtracting radical expression. Now, what you see here is what we have done before, is adding and subtracting with variables. So, if you look at this one, 3x plus 4x, we can combine them because they both have the same variable, the x. So we're just going to add the coefficient, so 3 plus 4, it will be 7x. Now over here, it's 2x minus 7x, and again, both of them have the same variable, so basically 2 minus 7, this will be negative 5x. Now the reason I'm doing this is to build the connection for adding and subtracting radical expressions. So, say instead of having 3x plus 4x, what happened? You had 3 square root of 2 plus 4 square root of 2. So basically, when we're working with radical expression, when you have a radical with a coefficient like 3 square root of 2 and 4 square root of 2, the square root of 2 are kind of like variables. So if they're kind of like variables, then it's going to be the same process as what we did up here. 3x plus 4x is 7x. So therefore, 3 square root of 2 plus 4 square root of 2 is simply 7 square root of 2. Now see how that my square root of 2 stay the same? So square root of 2, square root of 2, square root of 2 is the same thing. X, x, x. That's all it is. We're just combining the coefficient, the ones that are in front of the square root of 2. So over here, say that instead of 2x minus 7x, I had 2 square root of 5 minus 7 square root of 5. And again, if we think the radicals are like the variables, then we can combine the 2 minus 7, which would be negative 5 square root of 5. And that would be our answer. So again, notice how in this example, the square root of 5 stay the same. Square root of 5, square root of 5, square root of 5. So it's just like adding, subtracting with variables. So all I'm doing is combining, adding or subtracting the coefficient, the numbers that are in front of the square root. Now here, if you pay very close attention, I cannot simplify the square root of 2, that's why it stays the same. And over here, I cannot simplify the square root of 5, which just stay the same. So again, this is what you're basically doing when you're adding, subtracting with radical expressions. So in this example, I have negative 3 square root of 3 plus 10 square root of 3. Now these two, I can combine them because they both have the same radical, square root of 3. So all I'm doing is just combining my coefficient or my base numbers that are in front of the square root. So negative 3 plus 10, that would be 7, and then square root of 3. And again, I did not change the square root of 3. I want to be consistent. So this is my answer, 7 square root of 3. In this next example, I have negative 2 square root of 7 minus 9 square root of 7. I can combine these two because they both have the same radical. So I'm just going to combine the coefficient or the base numbers that's outside the radical. Negative 2 minus 9, that's going to be negative 11, and then I got to keep my square root of 7. And that is my final answer. So let's take a look at this example. We have negative 3 square root of 7 plus 5 square root of 6. But these two, we cannot combine them because they have different radicals, square root of 7 and square root of 6. And I can't simplify the square root of 7 and square root of 6. So since I cannot combine them, then you're just going to leave it like this. And there's nothing you can do about it. You can't add, you can't subtract, whatsoever. So when it comes to adding and subtracting, it's like adding and subtracting with fractions, adding and subtracting with variables, they both have to be the same. So in this case, we cannot add or subtract, so just leave it like this. In the event you have a problem like that, when you cannot add or subtract. But when it comes to multiplying and dividing, that is a different case. But in the case, or in the terms of adding and subtracting, here we cannot do it. Just leave it like this. In this next example, before we can work with subtracting 5 square root of 18 minus 7 square root of 2, I want to go over this little example here so that what we learned here can help you solve this example over on the right side. So on the left I have 4 square root of 20. Now we can square root of 20 because the perfect square 4 can go into 20. So I'll bring the 4 down. What I'm going to do with the square root of 20 is just like what we did before. We're going to break it down into 4 times 5. Since it's square root of 4 times 5, I can rewrite it as square root of 4 times the square root of 5. And again, I'm just bringing the 4 on the outside. I'm just bringing it down. Now the only one that I can simplify is the square root of 4, which is 2. And again, I can't simplify the square root of 5. I'm just going to bring it down. And again, we're just multiplying. And then the 4, I'm bringing it down. And again, we're multiplying. Now, since we were able to do the square root of 4, which is 2, basically like a whole number, now I can multiply this 2 to the 4 that was outside. So it's going to be 8 square root of 5. So 4 square root of 20 will simplify and become 8 square root of 5. So any number that you are able to square root, in this case the square root of 4, you're going to multiply to the number that's outside that you have at the very beginning. So you see how I brought down the 4? And then when I simplify, after I break 20 into 4 and 5, and then I did the square root of 4, which was 2, I multiply my 2 to that 4, which is how I got 8. Now I'm going to do the same process over here. So I can simplify the square root of 18, whereas I cannot simplify the square root of 2. So this part will stay the same. Right here, the minus 7 square root of 2 will stay the same. But over here, I want to simplify 5 square root of 18. So 5 will stay the same, and it will be on the outside. But the square root of 18, we can break it down into 9 and 2. 9 is a perfect square number. Just like over here, I'm going to rewrite it as square root of 9 times square root of 2. And again, the 5 is still there, doesn't disappear. And now I'm going to bring it down because we're going to simplify the square root of 9. So the square root of 9 is 3. And you can't simplify the square root of 2, so I'm just going to bring it down. Now we're going to do 5 times 3, which is 15. So this will be 15 square root of 2. And now I'm going to bring down minus 7 square root of 2. So since both of them now actually have the same radical, square root of 2, I can actually combine the numbers at the outside, which is 15 minus 7. So 15 square root of 2 minus 7 square root of 2 is 8 square root of 2. So that's my final answer, and let me box that up. So at first they don't have the same radical, that means we can't combine them. So the next thing is, can you simplify any of the radicals? The square root of 2, we cannot. That's the simplest it can be. But you can simplify the square root of 18. So therefore I break it down to 9 and 2, and then I could do the square root of 9, which is 3. And then I multiply that 3 to the outside number, which is 5. That's how we got 15. And at this point, they have the same radical, so therefore I can combine the 15 and the minus 7, and then I get 8 square root of 2. So again, if they're not the same radical, check if you can simplify one of them or both of them.